So we have this idea of an absolute value, but things get a little tricky if absolute values show up in an equation. So here's an example of an equation with an absolute value. Let's solve this equation for x. Absolute value of x equals 4. So remember what the phrase solve for x means. What we're doing is looking for all values of x that would make this equation true if we put in our number for x. Right? And if you imagine a number line, right? So here's our number line. What numbers would have an absolute value of 4? Well, 4 is definitely one of them, right? Because if we plugged 4 into this equation, right, we get absolute value of 4 equals 4, and then we check, is this true? Well, the absolute value of 4 is 4, and yes, 4 is equal to 4, and so x equals 4 is a solution. Is that the only solution, though? Are there any other numbers whose absolute value is 4? Well, yeah, there is another number whose absolute value is 4, and that's negative 4 over here, right? Both 4 and negative 4 are 4 units away from 0. So let's just check that negative 4 is also a solution. If we plug negative 4 into this equation, absolute value of negative 4, is that equal to 4? Yes, because the absolute value of negative 4 is positive 4, and that is equal to 4. So x equals negative 4 is also a solution. So the upshot of this is when we have an equation that looks like the absolute value, oh, my screen just did something crazy. I've lost my notepad. Okay, we're back. Let me clean up this mess here. The upshot of all of this is when we have an equation that looks like absolute value of something with the variable in it, when we have an equation that looks like something with absolute value of something with the variable equals a number, there are two ways to make this equation true. We could have the stuff inside, so the something, whatever it is, equals the number, or we could have that same thing, same something, equals the negative of the number. Right? So you can see that happening here. We have one solution is, since our equation was absolute value of x equals 4, one solution is x equals 4, but the other solution is x equals negative 4. So there are two solutions. There's the positive version and there's the negative version. And this happens whenever we have an equation that reads like this. Absolute value of something equals a number. Although, I'll talk more about this later, but the fact that this number is positive is actually important. If this number is negative, something different happens, which we'll talk about later. All right, so we get two solutions from this kind of equation, not just one. And it is important to record both solutions, because remember, when we solve an equation, we're looking not just for some number that works, not just some value for x that works. We want to write down every value of x that works. So for this equation, there are two solutions, x equals 4 and x equals minus 4. Some people like to combine these two and sort of be as brief as possible. And so some people will write that the solution is x equals plus or minus 4. So they'll use this plus or minus symbol just to indicate that x could be plus 4 or minus 4. That's an okay thing to do, but you do want to keep in mind that we are writing down two different numbers for a solution if we use this abbreviation, this plus or minus here. All right, so now that we know kind of the basics of how an absolute value equation works, let's work through one more example. So let's solve this equation for y, absolute value of y equals minus 6. Now the temptation here, based on the previous example, the temptation is to say, okay, well, y has to be plus or minus 6. But let's hold off on that for a second. Remember, we're looking for numbers that will work when we plug them into this equation. So if you think 6 is a solution, let's check. Is the absolute value of 6 equal to negative 6? Well, the absolute value of 6 is 6. Is 6 equal to negative 6? No. So that means 6 is not a solution. Okay, well, what about negative 6? Let's check negative 6. If we plug negative 6 into our equation, we get negative 6, absolute value of negative 6, and then is that equal to negative 6? But again, the answer is no, because the absolute value of the absolute value of negative 6 is positive 6. And is positive 6 equal to negative 6? No. So negative 6 is also not a solution to this equation. And of course, no other x value, right? 6 and negative 6 were the only possible values for y that might have worked in this equation, but neither of them actually do work. So that means that this equation that I wrote down, absolute value of y equals negative 6, has no solutions at all. That's a little bit strange to have an equation with no solutions, but I mean, that's what happened this time. So the point of these two examples, the original one where absolute value of x is equal to 4, and then the second example where the absolute value of y is equal to negative 6, the point is it makes a difference to our absolute value equation whether the right-hand side with the number on it is positive or negative. Right? An absolute value can't be negative because the absolute value forces it to be positive. So if you have an absolute value equation with a negative on one side, it won't have any solutions. On the other hand, an absolute value equation with a positive number on the other side will have two solutions, typically. I can make up exceptions, but typically it will have two solutions, like we saw with our first example, absolute value of x equals 4. While I'm on the topic, let me write down one more equation. What about the equation absolute value of x equals 0? Well, there's only one number whose absolute value is 0, and that's 0. So x equals 0 is the only solution to this equation. And this is just one single solution. So usually absolute value equations have two solutions if the right-hand side is positive, no solutions if the right-hand side is negative. If the right-hand side happens to be exactly 0, then there's only one solution.